When you're trying to solve a problem, you've got a choice. Do you go for the quick and easy win, the thing that looks best right now? Or do you step back and build a bulletproof master plan? That's the core dilemma between greedy algorithms and dynamic programming. Let's break down when to trust your gut and when you need to play the long game. And that's really the heart of it, isn't it? Do you just grab the best option that's immediately in front of you and hope it all works out? Or do you meticulously map out every possible turn to guarantee you end up in the best spot? This is the fundamental difference, the philosophical clash between greedy and DP. All right, so first up, let's meet our intuitive, super fast, but sometimes kind of flawed hero, the greedy approach. The thinking here is super simple. What's my best move right this second? A greedy algorithm makes the choice that seems best at the moment without ever looking ahead to see the consequences. It's myopic, it's short-sighted, and it's basically just hoping that a series of these small, immediate wins will somehow add up to a big global victory. Now, before we get into where these two strategies go their separate ways, you gotta know they share some common ground. Both of them only work on problems that have what's called optimal substructure. All that means is that the best solution to the whole big problem is built from the best solutions to its smaller parts. Think of it like a perfect Lego castle. It has to be made of smaller, perfectly built Lego chunks. This is a must-have for both, but as we're about to see, greedy needs one more special ingredient to actually work. Okay, so when does this live-in-the-moment strategy actually pay off? Let's check out a classic example where being short-sighted isn't just fast, it's actually perfectly correct. Imagine your calendar is just packed with meetings, right? Each one has a start and an end time. Your job is simple. Cram in as many meetings as you possibly can, but you can't be in two places at once, so none of them can overlap. How would you do it? The greedy solution is honestly beautiful in its simplicity. First, you just sort all the meetings by their end time. Then you pick the one that finishes earliest. That's your first meeting. Now you just go down the list and find the very next meeting that starts after your first one ends, and you pick it. You just keep doing that over and over. It's simple, it's fast, and it gives you the perfect answer. But why? And here it is. This is the secret sauce. This problem has a special superpower called the greedy choice property. It means that making the choice that looks best right now, in this case, picking the meeting that frees you up the soonest, is always guaranteed to be part of the best overall solution. You literally can't mess up by making that first choice. This property is pretty rare, and it's the only reason greedy works here. Okay, so greedy looks pretty good, right? Well, let's throw a wrench in the works and see what happens when that magic property just isn't there. Let's introduce a complication that totally breaks our simple hero. What if we add one little twist? What if each meeting also has a value attached? Maybe one is $1 million deal and another is just a 5-minute coffee chat. The goal is no longer about the number of meetings. It's about maximizing the total value. All of a sudden, picking the meeting that finishes earliest might mean you skip a much, much more valuable one later. Our greedy strategy is in big trouble. This right here, this is the textbook example of where greedy just completely falls apart. You need to make change for 6, and your coins are 1s, 3s, and 4s. The greedy move is to take the biggest coin you can, right? So you grab a 4. Now you need 2 more, so you take 2 1s. That's 3 coins total. But wait a minute, the best solution is obviously just 2 3s. The crucial point here is that the best choice at that moment, taking the 4, led to a worse overall solution. This is where we need to call in the big guns. When your choices have these tricky long-term consequences, you need a master planner. You need dynamic programming. See, dynamic programming is methodical. It doesn't guess, it doesn't hope. It takes a huge problem and smashes it into a bunch of smaller, overlapping subproblems. It solves each tiny little piece perfectly, just once, and then it saves that answer. Then it uses those saved answers to build up a solution to bigger and bigger pieces, until it's solved the whole thing. So let's go back to our valuable meetings problem. For every single meeting, DP doesn't just pick one. It carefully considers 2 options. It asks, what's better here? Should I skip this meeting entirely? Or should I take this meeting and add its value to the best possible outcome from all the previous meetings that don't conflict? It calculates both scenarios and definitively picks the maximum. No guesswork, just the facts. And for our coin change problem, it's the same kind of methodical thinking. To find the minimum coins for any amount, DP looks at every single coin you could possibly use. For each one, it says, okay, if my last coin is a 4, then my total coins will be 1 plus the best way to make the remaining amount. And the key is, it has already figured that out and stored the answer. It does this for every coin and just picks the true minimum. So, to solve for 6 cents, the DP process starts from the bottom up. It first finds the best way to make 1 cent, then 2 cents, and when it gets to 3, it sees that using one 3-cent coin is optimal. It stores this tiny fact: the minimum coins for amount 3 is 1. Now, for the magic moment. When it finally gets around to calculating the solution for 6, it uses its notes. It thinks, what if I use a 3-cent coin? It knows that means it's 1 coin plus the optimal solution for the remaining 3 cents. And because it already solved that subproblem, it instantly knows the answer is 1. So 1 plus 1 gives it 2. After checking this against all other possibilities, it confirms that, yep, 2 is the best you can do. Okay, that was a lot, I know. So let's put it all together. Let's create a simple checklist, a cheat sheet that you can use to make the right call every single time. Here it is, your cheat sheet. The core idea for Greedy is all about that instant gratification, making the best local choice. For DP, it's about patiently building the perfect solution from the ground up. The key property that lets Greedy work is that rare Greedy choice property. For DP to even be worthwhile, you need overlapping subproblems, so you're not just resolving the same thing over and over. And the trade-off is usually speed. Greedy is often faster, but DP is the robust, correct choice when your decisions have those cascading consequences. So let's boil all this down to the one single question you need to ask yourself to solve this whole puzzle. Okay, so picture this. You're looking at a problem. You've confirmed it has optimal substructures, so you know one of these strategies might work. Before you jump to that simple, fast, greedy solution, you have to stop and ask yourself this. Can I prove that my first short-sighted, locally optimal choice will always be part of a globally optimal solution? If you can't prove that greedy choice property with 100% certainty, then you have to bring in the master planner, dynamic programming.